Welcome to lesson 5.6, Inequalities in Two Triangles and Indirect Proof. So in our last lesson, we looked at a few different theorems related to inequalities in one triangle. Now we're going to look at a couple that are related to inequalities with two triangles, and then the idea of indirect proofs. So first off, two more theorems to introduce. Theorem 5.13 is known as the hinge theorem. And what the hinge theorem states is if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than that included angle of the second triangle, then the third side of that first triangle is larger than the third side of the second. So in this case, side VW is congruent to RS, VX is congruent to RT, angle V is 88, angle R is 35. So what that tells me is the side opposite the 88, side WX, would be greater than ST. And then we have theorem 5.14, the converse of the hinge theorem, which states if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the third side of the second, then the included angle of that first triangle is larger than the included angle of the second. So in this case, AC was congruent to DF, CB was congruent to FE, and their third sides, side AB was 12, DE was 9. Because 12 is greater than 9, tells me the angle opposite 12, which is angle C, has a greater measure than angle F. So the measure of angle C is greater than the measure of angle F. So looking at a couple examples, example 1 and 2. In example 1, it says, given side ST is congruent to side PR, how does angle PST compare to angle SPR? So in this case, ST, this side here, congruent to PR here. When we look at our diagram, we see the two triangles share side PS, so PS is congruent to itself. So then, based on what we know, we also knew PT here was 24, RS is 23. So PT being 24 was greater than side RS. So that tells me the angle PST right here would be greater than angle SPR right there because it's opposite 24, which is greater than 23. Now, the biking scenario, you can ignore the diagram that kind of printed up here because that did not print correctly, so I just pulled it down here to draw to make it easier to see. So our biking scenario says two groups of bikers leave the same camp heading in opposite directions. Each group goes for 2 miles, changes direction, and goes 1.2 miles further. Group A starts going due east. So Group A started here at camp, went 2 miles east, then they changed their direction 45 degrees north and went 1.2 miles. So here's our 45-degree change, 1.2 miles. Group B went west for their 2 miles, changed their direction 30 degrees toward the south, and then went 1.2 miles. Which group is further from the camp? Explain your reasoning. So I drew my diagram. Well, if I knew this is 30 degrees out here, 180 minus 30 gives me this interior angle of 150. Then if this one's 45 right here, 180 minus 45 gives me this interior angle of 135. So now I have a side, an included angle, and a side, an included angle, and a side. Well, 150 is a greater angle than 135. So the side opposite the 150 would be longer, meaning from camp to where group B is further than camp to where group A is. And we're using the hinge theorem to arrive at that conclusion. In example 3, they just want us to fill in the blanks with less than, greater than, or equal to. So in example A, we're looking at BA and DA. So in this case, I know that these share side AC. So AC, we have a side, and then BC, congruent to CD, is another side, and then an included angle. So I can use the hinge theorem. 50 is greater than 48, so the side opposite the 50, which is BA, would be greater than the side opposite the 48, which was AD. So BA greater than DA. In B, we're looking at angles 1 and 2. So again, I'm looking at the converse of the hinge theorem. Angle 1's opposite 29, angle 2 is opposite 24. So angle 1 being opposite the bigger number would make it the larger angle. So the measure of angle 1 is greater than the measure of angle 2. Then our last example based around those theorems. Example 4 says if PR is equal to PS and the measure of angle QPR is greater than the measure of angle QPS, which is longer, side SQ or RQ? Well, in this case, RQ right here, SQ right here, it depends which angle opposite those sides is larger. Well, it told me angle QPR, which is this angle right here, was bigger than QPS, so side QR would be larger or longer. And in this second part, again, PR equals PS, and in this case, side SQ is greater than side RQ. So which is the larger angle? Angle RPQ or SPQ? Angle SPQ would be the larger angle because it's opposite the larger side of SQ. And then our last concept for today's lesson is the idea of indirect proofs. So our introduction to an indirect proof. In an indirect proof, you start by making the temporary assumption that whatever the desired conclusion is false. Then by showing that that assumption leads to an impossibility, we're proving the original statement is true by contradiction. So an indirect proof is also called a proof by contradiction. So we take that original conclusion and we assume that it is going to be false. Then we show that by making that assumption, it's a logical impossibility to arrive at that statement. So that would be contradicting the original, meaning the original is true. So our 3 steps to do this. Step 1 is you want to identify the statement that we want to prove. And temporarily, we're going to assume that that statement is false by assuming the opposite is true. Then we want to reason logically until we reach a contradiction. Point out that the desired conclusion must be true because the contradiction proves the temporary assumption was false. So let's go through a few steps. So example 4 here asks us to write an indirect proof that an odd number is not divisible by 4. So if we're thinking about this, our given info would be that x is an odd number. We're dealing with an odd number. We're trying to prove that x, the odd number, is not divisible by 4. So in step 1, we're going to assume the opposite of this conclusion or the proof statement. So we're going to assume that x is divisible by 4. So x divided by 4 will give us some sort of whole number n, or whatever variable you want to use. So in that case, n being a whole number, so x divided by 4 is n, meaning x would equal 4 times n. Just breaking it down a little. In step 2, it says, if x is an odd number, by definition, odd numbers cannot be divided evenly by 2. However, x equals 4 times n, so we could think of x divided by 2 equals 4n divided by 2, which means x divided by 2, or 4n, replacing x because they're equal, 4n divided by 2 would just give us 2n. We know 2n is a whole number, so we can divide evenly by 2. That contradicts the given that x is an odd number, because the definition of odd numbers is that they cannot be divided by 2. But based on this equation that x is the same as 4n, we just showed that 4n divided by 2 is 2n, making it a whole number. So if we could divide that by 2, that's a contradiction because it cannot be an odd number and be divided by 2. So therefore, the assumption that x is divisible by 4 must be false, which proves that x is not divisible by 4. I know it's confusing. Indirect proofs are, again, a piece you just need to be able to kind of look at these 3 steps and go through the process. They're not going to be the foundation of everything we do going forward. So one more example of an indirect proof. So in this case, this indirect proof, we have write an indirect proof of the converse of the hinge theorem. So they gave us some given info. Side AB is congruent to DE. Side BC is congruent to EF. And angle AC is greater than angle DF. They want us to prove that the measure of angle B is greater than the measure of angle E. So our assumption is the opposite of this. So we're going to assume that the measure of angle B is not greater than the measure of angle E. So that means that either the measure angle B is equal to E, or the measure of angle B would be less than the measure of angle E. So in case 1, if the measure of angle B equals the measure of angle E, that means angle B is congruent to angle E. So that would mean triangle ABC is congruent to DEF by side angle side, and that would say that side AC is equal to DF. Well, according to our given, AC is greater than DF, so that's a contradiction. In case 2, if we try to see if B is less than E, if the measure of angle B is less than the measure of angle E, then side AC would be less than DF by the hinge theorem. That again contradicts our given that AC is greater than DF. So both cases, if it's equal or less than, contradict the given that AC is greater than DF. So the assumption that the measure angle B is not greater than the measure angle E cannot be true. So this proves that the measure angle B is greater than the measure of angle E. So for indirect proofs, you want to do your best to use these 3 steps to try to simplify the process. And again, I know with this being a new piece, this will get a little bit tricky, so don't freak out if you're struggling with the indirect proofs. The most important piece from this lesson are the 2 theorems here, the hinge theorem and the converse, and how you apply those.